Okay, so these would be the homework support for 1.7. We're going to be working on 3 through 13 odds. Now, I won't necessarily do all of them with you, but let's look at a couple of them. Can 3 or more vectors with unequal magnitudes be added together so their sum is equal to 0? The answer to that is yes. So number 3, take that vector, and that vector. Because they get back to where you started, the total is 0. And that has a lot to do with number 7. So number 5, it says an ostrich is running at a speed of 17 meters per second in direction 68 degrees north of west. Here's west. To be north of west, you got to be up above that. So that's 68 degrees, because that would be, that's north. And so there's a component of the ostrich's, oh no, let me back that up. Do that again. Okay, there's a component of the ostrich's velocity that is to the north, and there's a component that's to the west. So we take our 17 meters per second, and we really just need to break it down into its two components. The x component, okay, is always the cosine component. And so to find this side down here for the west, we would take 17 times the cosine of our angle, 68. And for the north, we would take 17 times the sine of 68. And we would spit out the numbers 15.8 for the north, meters per second. And for the west, we'd spit out the 6.37 meters per second. All right, let's look at a couple more questions. Number 7 is a pretty common one to struggle with. So we'll take a quick look at that. They give us a drawing down here, and I'm going to just take that drawing of our 3 vectors and I'm going to disassociate them from each other. So on question number 7, okay, we have vector A. Now, I'm just going to kind of give myself a baseline here. This is 21 degrees, and you can imagine that vector A here, which is 80 meters, can be broken into an x component and a y component. So we'll call this AX, which would be 80 times the cosine of 21, and AY would be 80 times the sine of 21. That's our basic trigonometry. To get the x component, we use cosine. To get the y component, we use the sine. Check your calculator's mode. Make sure that you're in degrees, not radians. And then you should be able to calculate 80 sine of 21. So for my y value, I get 28.7. Now, important to note is that this is a downward measurement for the y, so that's actually a negative 28.7. And if we do the same calculation with cosine of 21, we get 74.7. 74.7. Okay, so that's AX and AY. Now I can do the same with BX and BY. I am going to change the way that B is drawn just a little bit here to make certain things easier. I'm going to draw B this way, specifically so that my angle is measured against the x-axis. It makes it a lot easier to do all my calculations in terms of sine and cosine. So if that's 11 degrees there, then that means I must have a 79 degree angle here. You can sort of imagine that 11 goes there, so 79 goes out where I want to work with. And the length of B was 105 meters. Okay, so BX would be 105 times the cosine of 79. But that cosine of 79, that is a backwards direction, so this should come out negative. I'm just going to slip a negative in there. And then BY is the 105 times the sine of 79, making it the vertical. And because that is upward trending, it's going to come out positive. So I'll grab my calculator, 105 cosine 79. I'll keep that number handy, and 105 sine of 79. So for my cosine, it's 20.0. but again, that is a negative 20.0. And then for my y component, it's 103.1, and that would be positive because it's upward. So we're kind of looking at left, right, up, down to make sure we have positives and negatives. The real finish to this problem is that when we're trying to finish this off, we have to recognize that because it was a completed triangle, the a values, a, b, and c must add up to 0. So ax plus bx plus whatever cx is must be 0, and the same can be said for the y's. That allows me to, by process of elimination, figure out what each of these, what the c values are. So I ended up with 74.7, but I had a negative 20 for bx because it was to the left. Plus cx is going to equal 0. Well, this right here comes out to 54.7, and that's positive. So cx is going to have to be negative 54.7 meters. And then when I do ay at negative 28.7 plus by at 103.1 plus cy equals 0, it's going to imply that cy must be, let's take a quick check, 103.1 minus 28.7, get 74.4. Now when I go to an xy axis, it's left to negative 54.7 and up a length of 74.7, meaning that C would be pointed somewhat like that. Let's look and see if we made any mistakes with our with the way that that looks. C is down and left. I made a mistake with one of my numbers. So A is down and right, B is up and left. Let's take a look at that again. All right. A is right and down, so that would be a negative and a positive. And then B, Y is up, so that's positive. And BX is negative because it's to the left. Those numbers look right. Caught what my stupid mistake was. In order for CY to be 0, it's got to be a negative 74.7. This over here is 74.7, so in order for it to work, CY is going to have to be the negative of that. So scratch this drawing here real quick. It's going to be down this way. Okay, negative 74.7 there. Just using Pythagorean's theorem, 54.7 squared plus 74.7 squared. Now I'm not going to use the negatives because I know I'm squaring, and then I'm going to square root that. This should give me C as a final value. So this would be 74.4, no, 74 point, that's what it's supposed to be, 74.4. Excuse me on all of that. All right, 74.4 squared plus 54.7 squared. And if I square root that, I get 92.3. So 92.3 meters. We come back in here, we get the 92.3 meters. Now we need to know what angle it's at. We know it's going to be below or south of west. If you can imagine, we're rotating down this way towards south from west. The question is, what's the angle right there? To find that, we're going to use a tangent. Change colors here real quick and jump to the left. The tangent of my unknown angle would equal the opposite, 74.4 over 0.4 over the adjacent 54.7. And if I do a tan inverse or an arctan, I should get that theta second tan of 74.4 divided by 54.7 comes out at 53.7 degrees. Whew, that was a doozy, but I think we got through it all. And again, south of west. Question 9, 11, and 13. If you get stuck and you have some questions, come in and ask, but hopefully you understand how to break them apart and then combine individual pieces. And we'll see you in class.